So now we are going to use the simple linear regression model that we estimated from before, use this to do a bit of forecasting, and then look at our sums of squares. So as a refresher, we are estimating this model where y is equal to beta naught plus beta 1 times x1. We have found estimates of beta 1 and estimates or an estimate of beta naught, so we know what the numbers are here and here. And if I want to tell you what I think y will be, I can just plug in some value of x. So if I wanted to say, what is y when x is 10, I can take our projection from before and say y is equal to 31.82 plus 10.23 times x. If I plug a 10 in here, this is 31.82 times 10.23, 31.82 plus 102.3, and this is approximately 134.1. So if I were to ask or say, what do I think y is when x is 10, you just plug this 10 into our projection from before. It gives you a number, and this is what I think, this is what we expect y to be when x is 10. We can use this and information on the observations and information on the means of the y's to find our sums of squares. So the sums of squares from errors are the sum of the difference between y, the observed value, and y hat, our projection, squared. Anytime we see these sums of squares notation, or you see this summation, a difference, and a square, these things are all going to have the same general form. We're going to have a string of subtractions that have been squared and then added together. So all of our sums of squares will look something like this, and it's just a matter of what are we putting in these spots. So for the first observation, my y was 100. For the second observation, y was 150. For the third, it was 125. And for the fourth, it was 100. All of these values are observed values, and they come straight from the data set. So the table where I say, here are the values of these variables. The value of y hat is conditional on the x associated with each observation. So for this first one, it will be the same projection we did before, so 31.82 plus 10.23. But now I'm going to use the x that was paired with this first observation of 100y, or y is equal to 100, and this is 8. So I plug the 8 into this equation. It tells me what my projection is, and this is 113.63. So right here, y hat is 113.63. And I do this for each observation. I just plug in y. So for the second one, this is 10. We just found that, and that's 134.1. No, not that last one. Sorry. That last one, so x is 10 for both of these. The last one here, x is 6. I plug 6 into this, and I get 93.1, we'll round it to 9. Now it's 8. 93.18. If I go through, take all of these differences, so 100 minus 113.63 is negative 13.63. Square them and then add them together, I get my SSE is equal to 568.18. Okay. The sums of squares from regression follow a very similar format. So our SSR is equal to the sum. Here, it's the difference between our projections and the average of the y's squared. So we'll have, again, a string of differences squared and then added together. There are some people who see this and get a bit concerned, but if you break everything down into bite-sized pieces, it's a set of subtractions, multiplications, and then additions. And we're all capable of this. It's just being able to translate what is happening here and break it down into these doable parts. So the sums of squares from regression use our projections from before, so I'm going to use those same y-hats I calculated just a minute ago, so 13.63. And the difference here is we're going to subtract off 118.75. That is the average of the y's. That number is the same for all values of y. And then here, the only thing that is changing is my projections, but I've just calculated those, so I can just bring these back over. And if I take these differences, so if I subtract 113.63 and 118.75, square that, and then add it to all of these other differences, that gives me a value, or a sums of squares from regression that is equal to 1150.64. Okay. The last sum of squares that we need to find then is the total sum of squares, so SST, and this is our value of y that we observe compared to y bar squared. So it has the same general format. It's a summation of squared differences, so we can write out all of this. I'm going to find all of these differences, square them, and then add them together. So y's are just from our data table. Y bar we found before, that's 118.75. That's the same for everybody. So with this, I can take these differences, square them, add them together. The total sums of squares then are 1718.75. And we'll talk about what we do with these things in just a moment.